All right. Well, good morning. Thank you so much. It's a great pleasure to speak to you all about algorithmic recommendations at the New York Times. My name is Anna Coenen. I'm a director of data science at the Times, and I lead a team building algorithmic recommendations. And that's what I'll talk about to you all today as well. So I'm going to start with a question of, why does the New York Times use algorithmic recommendations at all? It's a good question to ask. One way to look at this problem is that we publish over 100 pieces of original journalism every day. Very, very prolific newsroom, of course. And that means even if you are a frequent New York Times reader, it is really, really easy to miss important stories. Even if you come back to our homepage a couple of times a day, due to the limited amount of promotional services, it's very possible that you will miss a story that you would have really liked to read, but you simply weren't there between the hours of, let's say, noon and 4 when it was promoted on home, for instance. This problem is exacerbated for readers that use small devices. Promotional space obviously shrinks as people use their phones to read the Times, which they do more and more. And that means that algorithms can really be used to step in to help readers discover and not miss relevant and useful content across our products. And we like to think of it as something that works in tandem with our newsroom in order to help them amplify editorial judgment and really be smart about how we deploy algorithms to do so. Before I go into detail about how we approach this at the Times, I wanted to give you a brief overview of where algorithmic recommendations actually play a role if you are an avid New York Times reader. One place you might see recommendations is in the recirculation areas that are in the bottom of a story page. So, if you're reading an article, scrolling down to the bottom, you're seeing recommendations from the same section, most popular articles, and so forth. These are powered through our algorithms. We've also recently leaned into using algorithms a lot on the New York Times cooking homepages and newsletters. So, for instance, if you are someone who regularly saves and reads and subscribes to NYT Cooking, you might have seen a recipes we think you'll love block on the cooking homepage. This is where we're actually using personalized algorithms to surface recipes that are similar to those that you've cooked before. We have a similar recipes ribbon at the top of every recipe page, showing you kind of similar recipes, as the name suggests. And then we've also recently added a trending module to, again, the cooking homepage, just in the app. We also are working in newsletters, and we're currently always looking for other opportunities to launch more algorithmic blocks on the cooking surfaces. We've also built out algorithms that power the For You tab in the app and the For You email, which is a personalized newsletter that gets sent every day to a large group of subscribers. And then most recently, and I will talk about this a little bit later, we've started using algorithms more on the New York Times homepage. So you may have noticed a relatively new block on the homepage called In Case You Missed It. And we've also likely started using them in other places, such as the Great Read, the Wirecutter block, and the Cooking block on home as well. Okay, so I'm going to talk a little bit about, sort of having done this for a few years now at the New York Times, some of the things we've learned and things that we're still learning about deploying algorithmic recommendations at the New York Times. And I'm going to start with the first kind of insight that I think is often important to keep in mind, especially if you're coming at it from a data science perspective, is that building a successful recommendation system is really about more than just choosing the right algorithm. There are lots of components to it, and you have to really understand the sort of ecosystem in which you're operating to make sure that you're thinking about not just a simple ranking algorithm. Okay, I'll be a little bit clearer about what I mean by that in a second. So to zoom out, first of all, I think it's kind of important to keep in mind all the considerations that we take into account when we design a new algorithmic recommendation experience in our products. So some of the considerations that we keep in mind are, the user need that we're trying to address here, and that can really vary. In some cases, you want to, for instance, help readers catch up on stories they might have missed, like in Case You Missed It block case. Sometimes we're really explicitly trying to yield a personalized experience, such as in the For You tab or the For You email. And sometimes we just want to help readers find content similar to the one that they're already looking at. For instance, that's what we're doing with the cooking ribbon. Another really important aspect is, what is the editorial intention behind a recommendation experience, right? So the editorial intention behind, in case you missed it, might be quite different than maybe the Wirecutter block on home, or recommendations on the cooking homepage. So for instance, one big consideration here, and I'll talk about that a little bit later as to how editorial intention enters this process, is what should even be an eligible set of candidate stories that should be allowed to be recommended in a given place. This is one of the most kind of like crucial points where editorial intention enters the recommendation problem. And then finally, a thing that we always think about whenever we're designing a new experience is, what are their kind of like short, medium, and long-term goals and success metrics that we're trying to optimize for? Some things you might think of are, we want to increase the time readers spent on the site, or maybe just like the number of articles they click on. But other things we care about are things like breadth. Are we making sure that we're exposing readers to the breadth of the coverage that the New York Times produces and not sending them down a rabbit hole of reading more of what they've already read in the past? And then potentially, and again, this is more potentially an editorial goal. We sometimes want to think about, are we exposing not enough people to really important stories? So there are stories that we just want everybody to see, have really, really big investigative pieces. And so one of the metrics that we might care about are we exposing enough people? Are there enough unique users that have actually seen this story or read a given very important story? And so in order to kind of like address and tailor a recommendation experience to whatever the answers are to each of those questions, we've built a pretty flexible recommendation system at the Times. And here you're just seeing the three main components that enter the system, and kind of like the components that can be tweaked and tailored to every given set of requirements. So every recommendation experience, and think of an experience just like a block on the homepage, for instance, starts with the concept of a pool. So behind every recommendation experience, there is a pool of eligible stories that are allowed to be recommended. This pooling step can obviously happen in batch. It could be updated regularly in an automated fashion or through a person. The next step is, and this is now what's happening in real time, a ranking step. So this is where we're taking everything that's in the pool and we're sorting it by some sort of rule or algorithm. And then after the fact, the final step that we found to be very, very useful is what we call the finishing step. So after stories are ranked, we have the capability to go in again and change some of the orders around based on a set of rules or filters that can be really, really, really flexible. To make this a bit more concrete, here are some examples of sort of the kind of ways that each of these components can be applied. So pool creation in our case can be done through a manual process. So an editor can go in and say, these 5 stories should be in the pool for the great read, for instance. Or they can be entirely automated through a query against our CMS, basically. And those two things can be combined. So we have cases where we might have a query automatically generate a pool, and then editors can go in and edit it further, adding things, removing things, and so forth. Ranking mechanism, this is really where I think the kind of like classic recommendation data science work mostly happens. So ranking algorithms obviously are the kind of like recommenders that you might read about in the literature. So these are personalized or non-personalized recommenders that can be optimized for a myriad of objectives. But I would also call out that, a simple ranking mechanism could be something like sort stories by their publication date. And that is something that in some cases we may want to do. So we've built this step in such a way that it can be a complex algorithm that ranks a set of stories, but it could also be a really simple numerical sorting step, for instance. We've also built out ways to combine different rankers with each other. So if we want to, take a optimized algorithm of sorts and combine it with a more simple rule, we have built ways to kind of like linearly combine those two, for instance, with each other. And then in the finishing step, This is where we're doing things like deduping. Which is what we do very, very often, we maintain a 30-day reading history of logged in users in a real-time data store that allows us to do things like removing stories that a reader has already read in the past. In the finishing step, we've also done things like diversification over a set of recommendations. So if you can imagine, we sometimes don't want to make sure that we're not showing maybe 5 stories on exactly the same topic or very, very similar stories. So this is a finishing function that can decrease the likelihood of similar stories appearing next to each other. And another finishing function could be what we call prioritization. So for instance, we have the ability to take in stories or information about stories that editors would like pinned at the top of a package. And so in the finishing function, we make sure those kind of like rules are respected and enforced. I should say that we run experiments on each of those components. So we have ways to experiment on different pools, different ranking algorithms, and different finishing functions. And we do so constantly in order to compare the impact that these have on core metrics that we care about. Okay, I'm going to move on to sort of learning number 2. And we are not the first ones to realize this learning, but I do want to talk about it because one I think real winner that we found in terms of recommendation algorithms for our use case have been deploying MultiM Bandits. They work really, really well for the news recommendation problem. So I want to talk a little bit about how we use them and why we like them. So recommending news has a couple of sort of like unique challenges that might be a little bit different than recommendations in other domains, such as, I don't know, recommending media from a more static catalog. So some of the unique challenges we face is that because of the pace of publication, we face an ongoing article cold start problem. We publish multiple stories, often per hour. And so there's always new content to learn about. We also have a user cold start problem. So a lot of people visiting the Times are not logged in subscribers. We don't know very much about them. Stories in the news domain often become stale very fast. So a story, especially in times like these, where the news cycle moves really, really fast, stories published at noon may no longer be relevant to readers 3 hours later sometimes. But the other thing that's interesting about news is that relevance does not actually decay at the same rate for all stories, right? So a news story on a heavily developing storyline might decay really fast and become out of date within 3 hours, but a big investigative piece might stay relevant for many, many, many days, or even be evergreen. So evergreen content like certain feature stories we publish or recipes. Obviously, in these cases, some of these content types don't decay at all over time. And so we want to figure out, we need a way to kind of like deal with not just decaying everything at the same rate, but respecting the fact that some of our content decays fast, some of it decays slow. And we find that MultiM Bandits have been a really, really useful modeling approach in meeting those challenges. Some of the benefits are that about MultiM Bandits or MIBs is that they can learn about new items in a really, really fast way. Because they have a built-in approach to exploring and then exploiting items and learning about them in real time. We also find that when we set them up in the right way, and I'll give you an example in a second, they can track changing rewards over time. So they can do really well with this sort of like non-stationary reward associated with the news problem. And also they're quite flexible in that they can be personalized if you're using a contextual MultiM Bandit, or they can be completely non-personalized as well, working well for new users about whom we don't know very much, for instance. Another nice feature is that they can accommodate different optimization metrics. So you can set up a bandit to optimize for something like a click, but you could also swap it out for something more sophisticated like time spent or something, anything that you can measure as a quality metric of user engagement. I wanted to quickly talk you over kind of how the particular bandit that we have implemented. This is actually based on a by now pretty old but classic paper by Li-Hong Li and his co-authors. So it's a very, very simple contextual bandit setup, but it works really well for us. So the bandit that we use learns to predict the rewards associated with showing a story just as a simple linear combination of contextual features. So the reward here can be anything like a click or time spent. We've started looking at clicks that at least yield a certain amount of reading time. So we've looked at, for instance, only count clicks if people actually stay for at least 30 seconds, making sure we're not counting fast bounces, for instance. So that's your reward. The items here are obviously articles that we're trying to recommend, and then X in this case might be context variable. If you're setting up this up as a contextual bandit, note that if you're not using a personalized or a contextual bandit at all, you can still use this approach, and then simply learn a one constant term per article that captures the expected click-through rate or whatever other reward you're optimizing for. Sorry. Okay. So that is the setup, simple linear combination, trying to learn, how much do people engage with a given article. And then we actually update this model based on fresh incoming data every 30 minutes. And this has been a crucial component of making contextual bandits work for us, is that we have to retrain them very, very, very often. So we basically update our model matrices on fresh engagement data, seeing how people interact with the recommendations we made. Another step that we've added in this learning phase is that we actually decaying observations using an exponential decay, so that we give more weight to recent data compared to older data. And this has been a really, really important component, especially for recommending news items that decay really fast or decay at different rates, as I said on the previous slide. And then what we do in real time when we're actually making recommendations is that we're simply, for every article, we're sampling from a normal distribution of the expected reward for each item, and then rank stories by this sampled reward. Important here is that there's a parameter in here that governs sort of the dispersion of that distribution. So you can imagine having sampling from a broader distribution gives you a more exploratory behavior on the bandit, and if you use a smaller value of that parameter, you're going to be leaning more towards exploiting. This means that every time we run a contextual bandit, MultiM Bandit, we also need to tune these kinds of parameters as well. Okay, couple of things to watch out for that we've learned when applying MABs. I mean, I think MultiM Bandits are great, but there are a couple of gotchas to keep in mind. One of them is that they require really high quality impression and engagement data. So again, we train every 30 minutes. So we need to know, what did we recommend, and then how did people engage with our recommendations. They have to be trained often. They need parameter tuning. So some of these models might not work out of the box before, without trainings, things like the decay parameter or exploitation parameter. And while they are really, really good at optimizing sort of like short-term success metrics like clicks or time spent, we do find that we need to be kind of like thoughtful in how we combine them with really, really good pool curation, editorial guardrails, and potentially even like relevant counter metrics in cases where we care about more than just engagement. Because bandits are excellent at just predicting what people or optimizing what people would click on, and that's often great. But sometimes there are other things we might care about, and so yeah, they have to be kind of like embedded in other processes. Right. Moving on to the third learning, and this is something I've been recently extremely excited about, and an area that we're still really, really just dipping our toes into, is that algorithmic recommendations, especially at the New York Times, can and I think should be used in tandem with human expertise. And we're really trying to hone in on ways that we can use them to amplify editorial judgment as well. So what we've started doing more and more is that we're really collaborating very closely with the New York Times newsroom and also our product organization to kind of like address these very unique challenges and opportunities that come with recommending news at the Times. One of the big privileges of working at the Times is working at an organization where we actually have experts in their field in-house. That can sort of like augment how we approach recommendations, and it's really changed how we approach the problem. So I should have said above, and I should say it again here, is that we don't think of algorithms as a way to replace editorial judgment at all, and we really want to use it instead to actually amplify our editorial voice, and just use them as a way to be smarter about how we promote stories in such a way that makes it possible for readers to not miss stories that we really want to really want them to see. And as part of that, we are starting to really think more strategically about building interfaces between these kind of like algorithmic components that I just talked about, so pooling, ranking, finishing, and the editorial workflows that already exist, for instance, the workflows that the newsroom uses to program the homepage. I'm going to give you a little example of a homepage block we launched recently. It's called In Case You Missed It. You may have seen it on the homepage. Actually, right now, it's no longer such a kind of horizontal carousel. It lives on the side of the page. If you're looking for it, it's a space on the right-hand side. And conceptually speaking, it was a homepage module designed on highlighting important enterprise stories that are no longer promoted elsewhere on home. So these stories are sort of getting like a second opportunity to be read by readers coming to their homepage after they've already had their kind of like first promotion cycle on there. And to make it most useful to our readers, the focus of this blog is really to be on stories that we think they haven't already read or seen before, but we think they should read, or at least see. The pool that we're using to power this block is pre-selected from an automated from a query looking at past homepage promotion, but then it is heavily supervised and edited by editors on a daily basis. So our colleagues on the news desk at the Times can go in and say, remove things from the pool if they think it's not a good story to appear in this blog, or add stories that we may have missed through an automated approach. That is sort of like the first way that we're interfacing between editors and what the algorithm is doing. But then after that, we've also developed the capability to allow editors to pin priority stories to the beginning of a package. So whenever there's been the story that we feel, irrespective of how engaging it is, this is a story that people should see if they haven't seen it already, and we really hope readers will read it. We can pin those stories, and editors can pin those stories to the beginning of the package, and it'll remain there until a reader has actually read it. Or at least seen it a number of times without ever clicking on it. So we kind of like have a way to give some of these important stories a chance to be discovered by readers as much as possible. And then the remaining stories are actually ranked by a MultiM Bandit, unsurprisingly, that optimizes for kind of like I already said, we're looking at more like healthy clicks. So not just did people click, but also did they click and then read. And we're actually combining this MultiM Bandit with another component to capture some editorial weight. This is where we're using just like a linear combination of two rankers, where the second component is a weight based on the prior promotion history of an item. So we give more weight to stories that have appeared higher up on the homepage for longer. This is something that is a little bit of a heuristic approach of approximating editorial importance, something that we definitely want to build on and get better at and collaborate with our news desk colleagues on. And then after running the ranker, in our finishing functions, what we do is we apply deduping, removing stories that your reader has already read or seen a certain number of times, so knowing that they're truly not interested in it. All right, and so we find that when testing this kind of combination of manual pool curation and then algorithmic recommendations has really allowed us to not only increase engagement. The MultiM Bandit does a good job of making sure we're showing stories that people actually want to read, but we've also really increased the exposure of important enterprise stories by giving them a second chance to appear on the homepage and be exposed to readers that haven't read them already. Which is something that we really truly care about. We invest a lot in our journalism, but in terms of fast news cycle, again, it is so easy for readers to miss important stories, and so this is one of those cases where I think an algorithmic approach has been very, very helpful in trying to mitigate some of that kind of like effects of the fast pace and the likelihood of people missing stories. and say, watch this space. This is something, we're still in the early stages of experimenting on this particular package. We continue to iterate. We want to make it more useful to readers. We want to get better at capturing editorial judgment and combining it with algorithms. And we really are only scratching the surface when it comes to building out a joint workflow between editors and algorithms as well. That is all I have for today. Thank you so much for listening. Please, if you have follow-up questions, do get in touch. You can email me. You can find me on LinkedIn. And yeah, I'm happy to take questions in the live session as well. Thank you so much.